An electric toaster uses nichrome for its heating element. Nichrome is an alloy which is made up of nickel and chromium. When a negligibly small current passes through it, its resistance at room temperature, that is at 27 degrees Celsius, is found to be 75.3 ohm. So one temperature is given. What temperature? 27 degrees Celsius. At that temperature, how much is the resistance? 75.3. Fine. What next? When the toaster is connected to a 230 volt supply, means current will flow in it, right? How much voltage is given? 230 volt. What is happening? Let's read that first. Voltage is 230 volt. The current settles after a few seconds to a steady value of 2.68 ampere. Why is it written that current settles? What does this mean? See, this is how it will work. First of all, when you turn something on, its temperature will be less. Okay, 27 degrees actually. When current will pass through anything, when current flows through anything, you know that it becomes hot. I'm sure you would have noted that. It would still be hot. Is that clear? I'm not kidding. It would still be hot. Why? Because whenever current flows through a wire, it heats it. Okay, other than that one. Okay? Is it clear? So when it gets hot, the temperature will increase. Generally, wires are made up of metals, and in metals, if temperature will increase, resistance will. In a metal, if temperature will increase, resistance will increase because resistivity will increase. Is that okay or not okay?
Yes.
So first, its resistance would be less. When चालू થાય ત્યારે cold હશે. Its resistance will be less. As current will pass, it will become hotter and hotter. Temperature will rise. So its resistance will increase. Finally, when everything comes in equilibrium, means surrounding and that object comes in equilibrium, temperature will settle. But now temperature would be higher than earlier. એટલે પહેલા 27 હતું પણ હવે 27 નહીં. Did you understand? It will be more or less more because of flowing of current it is hot. Okay? So this resistance will also not be 75. It will be more than 75. Did you understand? So now finally, when in equilibrium, this is the voltage and this is the current. What do we have to do? What is the steady temperature of the nichrome element in a wire? What is the steady temperature of the nichrome wire when this happens? Did you understand? Starting માં current છે ને થોડો વધારે એ resistance ઓછો ધીરે ધીરે resistance વધવા માંડે એટલે current વધતો. Okay, so V is 230 volt, I is 2.68 ampere, and we want to find out how much will be this final temperature. પહેલા તો 27 હતું agree, but now it is unknown. We want to find this. Question clear? Okay. Alpha is given. What is that? 1.70 10 raised to minus 4 per degree Celsius. We will solve this question and then we will talk about what you did by taking two different reference temperatures. Everything? Yeah. Where is it? How many of you have done it? Okay, probably we have a few. Right, so say just one. Do it. Okay, let's finish this first. So here what we'll do is alpha's value is given. This is the initial condition given. So we will take this as reference temperature. Did you understand? So T0 is this, R0 is this. Now we have to find when the V and I values are this, what is T? Temperature find out what resistance was it. You understand because all these quantities are related with resistance. Can we find resistance from this? Yes. In steady situation or steady state, in steady state means current becomes constant, right? R is equal to how much? V by I. And that should be equal to R0 1 plus alpha into delta T. Did you understand this step completely? પહેલા આટલું જો આ તો સમજાય R equal to R0 1 plus alpha delta T. And we know that resistance will be equal to V by I because voltage of that and current is also given. What it was correct. Do we have all values? R, yes, we can get it by V by R0, yes. 1 alpha given, and instead of delta T, what can we write? T minus T0. Understood? Okay, I'm doing this on you. Fine. Okay. Now, let's go to exercise. There are some homework questions for you. Um, yes, 5, 6, 7, 8. Exercise question 5, 6, 7, 8. 8 तो आज से खाली नंबर बदल देना. Okay, 5, 6, 7 and 8. You all definitely give it a try. If you don't get the answer, you make sure you ask me tomorrow. Alright. પૂછી લેવાનું હોમવર્ક આપ્યો એ તમારે કરવા માટે જ છે. મારે ચેક કરવાથી તમને કઈ ફાયદો નથી, પણ તમે કરો એનો તમને ફાયદો છે. બરાબર ને? So you do it honestly, that will be helpful to you. Okay, well then. Now that question of deciding what is reference, let's talk about that. So who has done all that calculation in some other way by taking reference as શું લેવાનું હતું? 100 લેવાનું હતું ને? Okay, how many of you have done that? Okay, are you getting the same answer? You're getting the same answer? Yes or no? Who's getting the same answer? Who's getting a different answer? Alright, let's see. So can you tell me the values once again? One resistance was 5 ohm and temperature was 0 degrees Celsius. Okay, so this is example which one? 3.4. Okay. Right. So this is one temperature. Another temperature 100 degrees and 5.23. And one more temperature, we don't know. And 5.795. Okay. Right. So we have to take this as a reference and this as a reference. Correct? You get it? So equation to okay, let's call this T1 and let's call this T2 and R1 and R2. So we're going to have well, same relation to what is R2 minus R0 upon R1 minus R0 equal to T2 minus T0 upon T1 minus T2. बराबर क्या नहीं? Okay. Okay, now what happens here? R2 minus R0. You get the 0.7 and you get the answer, right? 5.65, yeah. Upon R1 minus R0, and the minus 0.23 is equal to T2 minus T0. So that is T2 minus 100 upon T1 minus T0. That is T1. No, sorry. Minus 100. Yeah, sorry. Minus 100. T1 minus T2. So T2 minus 100 is equal to 56.5 upon 0.23. ये हो जाता है. तो ऐसे करो. मैं प्लस अच्छा भेज देंगे मैं. 245.6. Okay, therefore T2 equal to 345.6. बोला मैं तो exactly same है जब 347 हो. Okay, interesting. Actually, after writing this equation, I can see why we are getting the same answer. Because it is the slope of a line. It is the slope of a line. बराबर नहीं? नहीं. y2 minus y1 upon x2 minus x1 y2 minus y1 upon x2 minus એવી રીતે છે ને. Though I also see where it could cause problem in these kind of situations. When you need to put or when you have some relation of alpha, then it would cause problem. એટલે તમે આ ફોર્મ્યુલાથી કરવા જાઓ and if you take a different r0, then you will not get that. આમાં વાંધો કેમ ન આવે? Because this is the slope બધે same method. But here when you write it in this form, taking a different value of r0 would mean you will have to change alpha to it. For example, in this particular question, we don't know what's the reference. So આપણે આને આ લઈ લઈએ. Okay, though we are not given any other temperature, right? But what we could still do is, if we consider this particular unknown temperature as reference of this. So the same of second same let's try. Here we કરી જોઈએ. Okay. So just to investigate this one question, are we free to choose any reference and always get the same answer? My experience says no. કારણ કે ઘણી વખત મેં એવું જોયું છે કે ક્વેશ્ચનમાં અલગ રેફરન્સ છે કામ થતા. Let's see. So if we take this the other way around, so R is 75.3 and R0 is how much? This one. I can do that. So we are going to get we are going to 85.8. Okay. 1 plus alpha. What is alpha? 1.7 into 10 raised to minus 4 into delta t minus what? 300 minus 27 minus t. Is that okay or not okay? Yes. Did you understand? Because we are taking not this as reference but this as reference. Got it? Yes. Please use 4 or 5 digits. 0.8 7 6 2 okay, that is equal to 1 plus 1.7 into 10 raised to minus 4. એનું એટલા બધા કેમ લખી દાખલ છે આના. Okay, so this is what we are getting. હવે આમાંથી સબટ્રેક્ટ કરો એટલે શું આવશે? 0.777321 so negative what to change કરીને લખાય. So this will be negative here, so a minus માટે આને આપણે ઓલું બનાવશું and this is divided by 1.7 and then multiplied by 10 raised to 4. So that is going to be t minus 27. Those are તે આવી જાય તો ઉપર બરાબર ને. પાછળ આ તો એક્ઝામ્પલ હતા. What do we get? આમાં 745 તમે ઓલી મેથડમાં તો હતું 847 quite a lot of difference. એટલે એવું નથી કે પોઈન્ટમાં ક્યાં ઓછા વધુ લીધા એટલે ઓકે એનાથી ઓલો મોટો ડિફરન્સ. So this is the problem I was telling you about. કે ક્વેશ્ચનમાં કંઈ નો આપ્યો હોય તો રેફરન્સ ક્યાં લેવાનો? ક્વેશ્ચનમાં લખેલું હોતું જ નથી જનરલી where is the reference. So this is always arbitrary, right? એ બહુ પ્રોબ્લેમ છે. તમારી ખબર નહીં તમે યાદ રાખો તો સારી વાત છે. બાકી મેં તો ઘણા બધા ક્વેશ્ચન સોલ્વ કર્યા પછી આપણે આન્સર ન આવે પાછળ સોલ્યુશન જોઈએ તો એમ અરે આ લોકો તો આમાં રેફરન્સ તો હવે કઈ મતલબ. there is no logic whatsoever. कोक बार 0 डिग्री सेल्सियस ले ले, कोक बार जो फर्स्ट टाइप वो ले ले, like here. Not very good. So like that it's a bit weird. Okay. So in no solution, I don't have any solution. Sorry, I only have the problem here. I only have the problem. But I've seen that normally nothing else is given. The pela is that okay? At least that is what seems to work in these textbook questions. If my answer no have part of the homework na so okay, jo. Okay. Fine. Let's go over to the next thing. Power and all. मैंने क्या दिया एग्जांपल अच्छा हम लोग कराना तो ना 2 एग्जांपल 2 दिखाएंगे यस और नो रिप्लाई देता है चलो पहला 2 करते हैं it's just based on theory not much to do really खाली वो concept है एग्जांपल 3.2 क्वेश्चन मार्क का जो है In example 3.1, electron drift speed is estimated to be only few mm per second. I will not answer 1 mm per second. In the range of a few amperes, for currents in the range of few amperes, means like current is 1.5 ampere. Okay, good. So we are getting drift speed as 1 mm per second. How then is current established almost the instant a circuit is closed? Circuit is closed, no meaning to that. Suppose here you have a battery and there is a switch and here is some wire through which current will flow. So the moment you close this, like current flows, that's what it is saying. Current flows instantly. Why does it flow instantly? Because the moment you close the circuit, this battery can create electric field everywhere. And you know electric field is created with the speed of light. આટલું જ કવર કરવામાં તો શું થાય how much time will it take very less time yes or no in some nanoseconds only in some nanoseconds the electric field is set up everywhere so the moment electric field is set up everywhere drift will start so that's why even if you close the switch here you know that चलो electron પહેલા અહીંથી drift થશે ધીરે then that would take hours don't you think एक बोलो सम होता है मैं वो जब कराता था ना एक्सरसाइज में क्वेश्चन है को होमवर्क that there is some wire and it has some length then how much time will electrons take to drift from one end to another end so the next question homework में मैं last time में देखा it takes a lot of time actually but series बात है 1 meter wire હોય ને 1 mm per second drift speed હોય તો 1000 seconds લાગે કેટલી વાર રાહ જોવાની You got what I'm saying? Yes or no? Then you realize it would be a very strange world. Switch. ચાલુ કરો પછી રાહ જો. હમણાં થશે પંખો. Okay? Even works. Scooter start કરો તો self start કરો તો self start ની switch દબાઈ. રાહ જોજે. થાય છે 10 મિનિટ પછી. અચાનક spark પછી થાય ને પછી પેટ્રોલ માં ignition. You got that? Yes or no? Yes. So that's why it would be a strange world to live in. So that electric field goes instantly almost, and that's why current is starting instantly. That's the answer. B. Electron drift arises due to force experienced by electrons in electric field inside the conductor. Yes. But force should cause acceleration. Then why do electrons acquire a steady average drift speed? Basically, this is telling you that if there is acceleration, shouldn't the speed increase continuously? Acceleration with the speed વધતી જાય એવું ન થવું જોઈએ કેમ ન હોય Think of a metal wire આ metal wire છે એની અંદર બહુ બધા ફ્રી ઇલેક્ટ્રોન છે બધાની સ્પીડ કેમ વધતી જ ન જાય because of collision yes or no you remember or not whenever electrons will try to drift or move they will collide in every collision they have to lose some energy did you get that overall what we have is on an average the drift speed is averaged out to be this value correct or not yes so the scooter you accelerate a scooter then stop ગમે એટલી વાર એક્સેલરેશન આપો સ્પીડ ઇન્ફાઇનાઇટ નો થાય. Make sense or not? Because it's getting stopped again and again and again. Clear or not? Fine. Okay. Third, if electron drift speed is so small, yeah, like 1 mm per second type, the electron's charge is also very small, then how can we still obtain large current? Okay, so this question is about VD and current. Relation between them, I equal to N E VD into A. So let's say we take a typical wire chalo jado go with the pen jado. Okay or not? Okay, so A ની value કઈ એટલી બધી મોટી ન. Charge of electron very small. Drift velocity is very small. So current કેમ high આવે? દેખાય ને આ છે. This is the culprit. બરાબર ને કે નહીં? And what is value of n? Typically more than 10 raised to 25. એટલી મોટી value આવ્યું તો આની પહેલાના સમમાં આપણે વચ્ચે નેક્સ્ટ સ્ટેપ હતો જોઈજો એનું સોલ્યુશન. એમ હું તો તમને ઓછી વેલ્યુ કહું 10 raised to 25 એનાથી વધુ હતી લગભગ 10 raised to 29 બરાબર ને 10 raised to 29 આવશે. એટલી મોટી વેલ્યુ હોય એટલે આ બધાનો પાવર હોય જ તમારી બરાબર ને 90 આનો ડ્રિફ્ટ વેલોસિટી નો -3 અને એરિયા નો સપોઝ -5 હોય તો આનો 29 આ બધા ઉપર બહાર got it. So that's what is happening, right? So simple answer, number density of free electrons is extremely high in conductors. Number density of free electrons is extremely high. That's what. Insulator no that. You realize why? Because insulator don't have that many free electrons. Okay. So like it is simple. Okay. How તમારે exam માં નહીં લખવાનું. Simple લખવાનો હાફ માર્ક ઉડી જશે. આ રીતે હજી લિમિટ નથી બોલતો. એવું ન લખતા. Simple. You don't know this. એવું લખાય પેપરમાં. Why are you asking me? You don't know. Okay. D. When electrons drift in a metal from lower to higher potential, does it mean that all the free electrons of the metal are moving in the same direction? Question 2. It's saying that drift velocity is in which direction from lower to higher potential? देखो जो high the battery है तो current arm close है. Yes or no? Clear or not? Then electric field will also be right side. Drift velocity will be towards the left side. समझ पड़ी कि नहीं? Drift velocity will be towards the left side. What's that? So it is saying that drift velocity is opposite to the electric field or to the direction of current. So the question, read it again. Does it mean that all the free electrons are moving in the same direction? Yes or no? All the free electrons are moving towards left side? No. So they are drifting. They are drifting towards left side, but they could be moving in any direction. Don't forget random motion. It's like lots of crows trying to fly in wind. But they are drift to windy direction method. समझ पड़े कि नहीं? Okay or not okay? But some of them will still be flying in the opposite direction. बराबर ने? આ કેના જેવું છે? Crow ની flying speed 300 meter per second અને થોડો પવન આવે it gives a drift speed 1 meter per second. 1 mm per second. Sorry, not even 1 meter. समझ पड़ी ने? Okay, ફૂક મારી એટલે ઉડી ગયો crow. એના જેવું છે. E. Are the paths of electrons straight line between successive collision in absence of electric field? Suppose there is no electric field, then the force on this electron will be zero. समझ पड़े कि नहीं? क्या समझ पड़े? If electric field is zero, force on the electron will also be zero, ignoring gravitational force. बराबर? So then, if force is zero, acceleration is force zero, acceleration is zero. So in absence of acceleration, everything moves in a straight line. Do you remember that? Clear or not clear? Yes. Absolutely. Yes, a constant velocity means object moves in a straight line. Turn through acceleration. right? So, in absence of electric field, it will move in a straight. But if electric field is there, suppose we have applied an external electric field in this direction, let's say. So, I electron હવે અહીંથી આમ જવાની ટ્રાય કરશે તો સેજ ડ્રિફ્ટ થવા પડશે. Yes or no? In which direction? Electric field right side, it will drift. The electron will drift left side. Clear? So, આમ straight નહીં જઈ શકે ને because it will have sideways force. So, side માં force લાગે એટલે આમ સેજ turn થવું જોઈએ. Yes or no? સીધી વાત છે કોઈ તમે આમ જવાની ટ્રાય કરતા તો તમે આમ સાઈડમાં તો નોર્મલ કરે તો તમે આમ કરો. Got it or not? Yes. Okay, clear? So in absence of field it will curve. In presence of field it will curve, but in absence of field it will travel in a straight line. Is that okay? But in someone? Okay. But how much is that curve? ये જોવા જેવું. Compare the velocity of random motion and compare that with how much drift velocity it can acquire. બહુ ઓછી હોય ને. તો એનો મતલબ કે કર્વ એટલે એવું નહીં કે પહેલા આમ જતું અને હવે સીધું આમ જ જતું. It will be a very gradual curve કે almost કારણ કે એ metal ion નજીક નથી કર્યો. It's not like one is here and one is over. So you can almost consider it like a straight line. It's truly speaking it's a curve. But એટલું gradual હોય કે એનાથી કંઈ મતલબ નથી. તમે એમ કહો કે it's still approximately a straight line. સમજાણું? Okay. But yeah, one more thing. No. Now that we are coming to the end of this particular part of the chapter, everything that we have studied in this topic so far is a simple word. Is a simple version of the most accurate representation. And the electron C model there. It is called electron C model. Basically, this is saying that metal ions are like rocks and electrons are like water. There is a sea of electrons, free electrons, no sea. એમાં પાણી આમથી આમ થતું હોય the electrons ગમે ત્યાં જતા હશે, but rocks will remain at their own place. સમજાણું કે ન સમજાણું? Okay, another thing. This is an outdated idea. That is, it's not perfect, but it's simple. And it is a classical idea. Classical idea that is, it works based on the rules of classical mechanics, like laws of motion, velocity, energy, body vastu. Mathematics, acceleration, force, position, path, collision, with classical mechanics. But truly speaking, it's not correct. For various reasons. One of the simplest reasons that you can say is that electrons are not particles. જોવાય ને કેમિસ્ટ્રીમાં કે ના થતું એવું તો કે નહીં કેમિસ્ટ્રીમાં dual nature. Electrons are not like particles, they also have wave like behavior. એવું આવે કે નહીં? Sure. So all this is just like a simplified version or toned down version. જેમ જેમ આગળ ભણતા જશો એમ metals વધારે વધારે અઘરા થતા. What I mean to say, નાના હતા ત્યારે કેવું હતું? અરે metals, right? Some things are brittle and some are ductile. તો જે ductile હોય એને metal કહેવાય, પછી conduct કરે એને metal કહેવાય. એવું કહેતા કહેતા હવે what are metals and why are metals conductors? એનો આન્સર ધીરે ધીરે બહુ અઘરો થતો જાય. સમજાણું કે નહીં? પહેલા કેવું હતું? ચાર્જ flows easily. Metals, conductors. થઈ ગયું ને એવું? But step wise details માં જાઓ એટલે complicated થશે. Right? For example, if you ask a little kid, why can't this duster go through the bag? એ તો એમ કે નહીં થોડું જાય. એમાં કઈ સમજાવવાનું હોય તો આટલું નથી આવડતું. બરાબર ને? પણ ડિટેલ્સ માં જાઓ તો આનો આન્સર તો જોરદાર. Is that when you try to bring the duster close to the bench, the atoms of the duster and the bench will start applying repulsive force on each other due to their charges. So, this force ne apne normal force. What is it called? Normal force. So, એક અહીંયા થોડું નજીક આવશે એટલે તરત જ normal force લાગવા માંડે. થોડુંક એટલે કેટલું? in practical terms it should touch, but if you look at the atomic scale, there is nothing like touching. Atoms तो कहीं भी जा नोट जाए, atoms तो दूर है, but still they apply force on each other. એટલે એ force બહુ વધી જશે, ભાઈ તમે ગમે એટલું જોર લગાડવા જાય જ નહીં. You get that? એટલે આ process એવી છે ને, air માં આમ જતું રહે, because molecules will go sideways, ભાગી જશે, because molecules of air can move, but molecules of solid can not move. Detail માં જાઓ તો આન્સર ઘણો આગળ સુધી છે, રાઈટ? એવું બધી વસ્તુ માટે. Is it not possible that when I put my finger close to this board, થોડો તો પાર્ટ અંદર નહીં જતો રહેતો? Yes or no? એકાદો એટમ See, I'm not kidding. These questions are very interesting. તમે વિચારવાની ટ્રાય કરતો એટલે આપણે એમ કહીએ કે this is opaque material. તો લાઈટ એની પર પડે તો લાઈટ અંદર જાય? ન જાય ને. એટલે તમે એવું કહેવા માંગો છો કે ઉપરની સરફેસ થી જેને બગાડને, એટલે ફર્સ્ટ લાઈન ઓફ એટમ્સ થી પાછું આવી જશે, સેકન્ડ લાઈન ઓફ એટમ્સ થી પાછું આવી જશે, બટ એટમ્સ આર મોસ્ટલી એમ્પ્ટી. બહુ બધી જગ્યા હોય તો લાઈટ અંદર ન જતી રહે. Do you have answer to that question? So, over the atoms હોય તો atoms હોય તો distance now, and are themselves atoms also empty? Yes or no? Yes. Okay. If light can pass through glass માંથી થાય કે નહીં પાસ? Is glass a solid? તો એમાં એટમ છે, એમાં એટમ નજીક નજીક જ છે, તો બેઝમાંથી કેમ નથી જતી? શું કે? હા, એની મરજી. ઓકે, તો લાઈટ ને કેવી રીતે ખબર પડી કે એની મરજી શું છે? Does light think? Does light have a brain? Does light decide anything? તો કોકવાર એવું છે લાઈટ ડિસાઈડ કરી શકે કે ચલો આ વુડ છે તો મારે વુડ માંથી જતું રહેવું છે આજે, જેમ કોકવાર તારે ભણવું નતું હતું, કોકવાર ભણવું હોય એવી રીતે. You understand what I'm saying? Okay, so there are so many things. એટલે આ actually આ બધી વસ્તુના આન્સર સિમ્પલ ટર્મ્સ માં તમે ભણી ગયા, that this is called opaque and that's called transparent. ખબર કેવી રીતે પડે, or what decides whether something is opaque or something is transparent? All of that belongs to quantum mechanics. એમાં લાઈટ એટલે ફોટોન અને એટમ વચ્ચે એવું ઇન્ટરેક્શન થાય ને તો એને બ્લોક કરે and it will throw it back. એને લઈ લેશે, ન જોતો જા. ઓકે, પછી અમુકમાં કેવું થાય, it will come to it, એને લઈ લેશે, પછી આ બાજુ જ ફેંકશે. Sometimes it will throw it back, sometimes it will throw it in the same direction. સમજાણું કે ન સમજાણું? Basically light always interacts with a medium. Light always interacts with a medium. Okay, why does it interact? ये આગળ આવશે આ ચેપ્ટર માં નહીં, in chapter 8. Okay, so let's continue. But yeah, it has everything to do with electricity. ये कोई दो, right? It has everything to do with electricity. Now next topic, mobility. बाकी है ने? આજે 11:30 મને એમ કે ચલો હવે ભગાવીએ, પણ પછી આ વાતે ચડી ગયા. બરાબર ને? Okay, what is meaning of mobility? Mobility means how easy it is for something to move. That's called mobility. समझ पड़ी कि नहीं? Sure. Now let me ask you some very basic questions. Which is more mobile? A house is more mobile or a car is more mobile? It has wheels. It can move. Okay. This chair is more mobile or this bench is more mobile? Mass. બરાબર ને? માસ આવે ને માઇન્ડ માં કે લડાવજો. Anything that has more mass must be less mobile or it should have less mobility. Basically, something that can just go around quickly or easily, that is called more mobile or has more mobility. So, the definition of mobility. The drift velocity acquired by charged carrier for unit applied electric field is called mobility of charged carrier. So, symbol of mobility is mu. M like with the mass again is mu. Okay, but how clearly go jo symbol બહુ ખૂટી ગયા છે પછીના ચેપ્ટરમાં બધું મિક્સ થઈ જવાનું છે. Okay, so mu is equal to VD upon E. Meaning clear? Definition out in the formula or vice versa. Got it? Okay, VD upon E. Now, a very simple thing. If you put VD's value, what's VD's value? E capital E upon M into tau. E capital E tau divided by M and niche capital E the same. So E cancel and this shall become E tau by M. Everything that we have understood so far is visible in this relation. That's mobility of a charge carrier is inversely dependent on its mass. Okay. Let's go to relaxation time. Suppose electrons want to drift, but वारे घड़ी collision साथ करे तो then they cannot move easily. Yes or no? Yes. So if relaxation time is more, what is meaning of relaxation time? Time between two collisions. एक बार collide પછી વધારે વાર લાગે. Then it can move easily. Is that okay or not okay? Yes. Sure. Yes. What if? So that's why if relaxation time is more, mobility is more. And charge, how does it depend on charge? Very simple. If charge of some particle is more, then electric field will apply more force on it. Yes or no? How much force electric field applies? Q into E. So if charge is more, electric field will apply more force. Then that means it can move easily. Yes or no? Everything clear? Formula basically, I mean, we have derived a relation, but to be very frank, you don't need to remember. And આનાથી કોઈ sum no. This is just for your conceptual understanding. And એવું કઈ tough નથી, યાદ રાખવા જેવું નથી. આ VDD formula આવશે. Okay, so no need to remember this. Fine. Now, but there is another relation about mobility that I want you to understand. કરાવો તમને પહેલા unit જોઈ. Unit of drift velocity શું આવે? Meter per second. આ જોઈને બધી યાદ આવ્યું. રિઝલ્ટ કેતા હતા પેપર જોયા તો કે યુનિટ નથી લખતા તમે લોકો બરાબર જરાય કાં તો લખ્યા જ ન હોય કાં તો ખોટા લખ્યા હોય એવું ન થવું જોઈએ. Be careful. Must write unit. Alright? So BD meter per second. અને જોઈને લખવાનું હોય જો કોઈને યુનિટ યાદ રાખવાની કઈ જરૂર નથી હોતી. બેઝિક્સ થી કરો તો બધું આવડશે. લેફ્ટ સાઈડ જોઈ લેવાનું કઈ ક્વોન્ટિટી છે. પછી તમે એમ કહો કે સર મેં તો આવું લખ્યું જ નતું તો પછી યુનિટ માં આવડે. લેફ્ટ સાઈડ લખવાનું mu or whatever that is. Okay, so meter per second divided by Newton per coulomb. યાદ આવ્યું ને? એ નહીં. So this you can simplify and write as શું આવે? Meter into coulomb. Coulomb meter upon Newton second. Complicated. Another way to write it. जो न्यूटन पर कूलम की जगह है वोल्ट into meter लगा है. Do you remember? No, volt per meter. Do you remember electric field? Another unit is volt per meter. Second chapter में आपको पढ़ेंगे. तो आने simplify करो तो શું થાય? Meter square volt per second. Did you get that? This is still not enough. But ये simplify आप volt की value को तो घणું બધું simplify. We'll talk about electric field. અહીંથી થઈ જશે આગળ. જો coulomb second per kg. समझ में क्या नहीं? Unit of mobility is coulomb second per kg. कितना बड़ा unit है? Good question for MCQ. Isn't it? Which of the following is not a unit of mobility? तो થાય ને કે ન થાય? Which of the following is not a unit of mobility? Okay. Again, you don't need to remember anything. ખાલી આ basics હોય વેલ્યુ મૂકો તો બધું થઈ જશે. I'm erasing all this. Okay. Fine. Now, relation of mobility with conductivity. Okay. પહેલા intuitively તમે વિચારો. If some charge carrier has more mobility, means it is flowing easily. If some charge carrier has more mobility, it is flowing easily. So conductivity is what? High or low? High, obviously. One more. If there are more charge carriers, then also conductivity will be high. Yes or no? Yes. So, એ બધા relate એ બધું આમ આવી જશે. Let's start. Mu is equal to Vd by E की derivation start third. Okay, very simple idea. Instead of V, D, if I write J by N E, and they were together. J is equal to N E and divided by capital E. Is that okay? What is J upon E? What is J upon E? Sigma. Yeah, microscopic form. J equal to sigma. So J upon capital E is sigma. Clear? So you can do sigma upon N E, or conversely, sigma is equal to N E mu. Okay, this is an important relation. Sigma is equal to N E mu. If you want to do a general derivation, means suppose charge carriers are not electrons, so आप लग सकते where Q is the charge of the charge carrier. Instead of E for electron, you can write Q is the charge of the charge carrier. So solutions माने मतलब काम आ गया. Okay, so that's it in this part of the chapter. Okay, we have time nothing. So we will end the class. Okay.